Alright, the top part of this worksheet is really just intended to acknowledge that radical expressions, what we call radical expressions, which simply refers to the square root symbol, can be complicated or difficult to get used to dealing with. They're not as simple as whole numbers. We can add 3 plus 3 to get 6, but if you add square root of 3 plus square root of 3 on your calculator and get some decimal value, it's going to be about 3.464. And if you put in radical 6 in your calculator, you get something totally different from 3.464. So the answer to this question, are these two things equal to each other, is a big no. Same with this question here. You can try it on your calculator. If you've got a calculator handy, I would try it while I'm talking right now. Punch in square root of 3 plus the square root of 5, get a decimal value. Then plug in square root of 8, see if you get the same decimal value. I mean, try it, see what you get. You'll find that they're different. I don't know exactly what you'll get, but I know they will be different. Whereas in this case, you put in square root of 3 plus square root of 3 and press the enter key and get something like this. Then you start over and you put 2 radical 3 and hit the enter key. Then you will get exactly the same thing. And so it seems that in some ways radical expressions don't behave like whole numbers do, and in other ways it seems like they do. Come down here, you can multiply square root of 3 times square root of 2 on your calculator, see what you get as a decimal, then put in square root of 6 and see what you get. It'll be the exact same thing. So you can multiply radical numbers together just like you can multiply whole numbers together. But try to multiply a whole number times a radical number. Well, you can't simplify that really into anything that is the same value. Put that in your calculator, see what you get. It's going to be something around 4.2. Put that in your calculator, it's going to be something around 2.4. These are not the same thing. You can't simplify this expression by trying to multiply these numbers together. But when they're both square roots, you can, just like when they're both whole numbers. So we're going to take advantage of this in learning to do the two things that I want you to learn how to do today. First of all, let's review some things. That if I ask you to write down an expression which is exactly 3 times x, you would simply write 3x. If I ask you to write an exact value of 3 times the square root of 10, don't you dare reach for your calculator and put in 3 times the square root of 10, because the calculator is going to turn this into an inexact decimal value, just like it will turn the pi key into an inexact decimal value. If I said write down the exact value of 3 times pi, you all learned in my class that you better write down 3 pi and not put that in your calculator and give me 9.42 blah blah blah. Same thing with this. 3 times radical 10 is just 3 radical 10 if I ask for the exact value. 3x times 4x, let's review this from algebra. We can multiply the 3 times 4, that gets us 12. Don't forget also to multiply the x times the x. That gets you x squared. Okay. And then square root of 10 times square root of 10. Well, if you need this reminder, okay, we can multiply square root expressions together just like whole numbers. And we would get square root of 100. And that is exactly the same thing as square root of 10 times square root of 10, but that's not simplified because what is the square root of 100? Isn't it exactly 10? That's what you should tell me if I ask for an exact and simplified answer. So let's apply these properties to these few problems down here at the bottom of the page, and then the next page will be left for homework. 3 times the square root of 2 times 5. I want to simplify this expression. Well, you can't multiply this radical by either of these whole numbers, but you can combine the whole numbers. 3 times 5 is 15. The radical 2 remains there. It doesn't get sort of combined in with the 15, or it certainly doesn't disappear. This is our simplified expression then, 15 radical 2. Here you can multiply the radicals together. and get a radical 10. The 3 doesn't disappear, it's still there. So 3 radical 10 is your final answer. Let me just remind you here that I've written a multiplication symbol there. I didn't put a multiplication symbol in here between the 3 and the radical 2. But you have to use your imagination and realize there is one there. Just like when we write 3x, in high school math, we don't write 3 times x anymore. You just write 3x and everybody knows that means 3 times x. Same thing when you're looking at an expression like this. You got to know that that means 3 times radical 10. We just don't ever write the multiplication symbol. Okay? In this one here, you can multiply the whole numbers and get 12. You can multiply the radical numbers and get radical 14. There's your final answer. 12 radical 14. Square root of 25. Wow, what is there to even do? Isn't that simplified already? What? Oh, wait, no. Square root of 25 is 5, isn't it? Sure. Okay. Don't ever leave a number like this unsimplified into a whole number. All right? If I want it simplified and you can give me a whole number, give me a whole number. Square root of 3 times square root of 12. We can multiply the radicals together and get radical 36. Circle. Wait a minute. Don't circle that. That's accurate and it is simplified, but it's not completely simplified because the square root of 36 is just 6. Don't overlook that. Okay? 9 times square root of 2 times square root of 2. All right, I can multiply the square root of 2's and get square root of 4. So I end up with 9 square root of 4. Circle. Wait a minute. Don't circle that. That's not completely simplified. What is the square root of 4? Isn't it 2? And now we have a 9. And so our final answer is 9 times 2. Well, it's not really our final answer. Multiply the 9 times 2. 18. There's our final simplified answer. All right? This is simplified a little bit, but this is simplified even more, and this is completely simplified. When I give you the quiz coming up soon on this stuff, I will insist that every answer be completely simplified. And if you only partially simplify it, it's just wrong. You're not going to get any partial credit. So make sure you simplify things all the way. Okay? Turn over to the next page in our notes. This will all be left for homework, this entire page. Let's go to page 3. And now we've got to learn another type of simplifying. Okay? Simplifying an expression like square root of 72. I'm going to work over here on the right-hand side, mostly on this page. I might come back and work on the left-hand side a little bit. Okay? Simplifying a number like square root of 72. If you put that in your calculator, you don't get a nice whole number. So you could fairly ask the question, well, how do I simplify that and leave it exact if I don't get a nice whole number out of it? Well, what we can do is, well, let me just show you. Let's turn back to page 1 here. You don't have to, but I'm going to show you. Since we can multiply 2 square root numbers to get a new result, we could also go backwards and say, hey, the square root of 36 is equal to the square root of 3 times the square root of 12. So if I started you with this expression and I said, break it down into factors that multiply together to give me square root of 36, you could write square root of 3 times square root of 12. You could also write square root of 4 times square root of 9, or square root of 2 times square root of 18. There's lots of answers that you could give me. So back to page 3. When I say simplify this, what you're looking for is factors of the square root of 72. Now there's lots of factors of the square root of 72. So you need to be strategic about this. Notice this note says that this method is about finding the largest perfect square factor. So you need to know what a perfect square is for this to make any sense. Perfect squares are the following numbers: 4, 9. Write these down in the margin of these notes here. 16, 25, 36. Where are these numbers coming from? What's the pattern here? Do you see it? What's the pattern? This number is 2 squared, right? And this number is 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. You can probably guess what the next number is going to be. 7 squared, then 8 squared, 9 squared, 10 squared. These numbers could go on forever, but we'll stop there. I am not, in this course, going to require you to have to deal with any perfect square numbers that are larger than 100. In the future you might have to, but in this course I won't. Actually, we kind of skipped a perfect square here. 1 squared is 1, but that's not going to be useful to us. You'll see why in a moment. So this is the beginning of a list of numbers that we call in math the perfect squares, because they all come from squaring a whole number. They're all numbers that if you take the square root, you get a nice whole number. Square root of 4 is 2, square root of 9 is 3, and so on. So we are looking for 2 factors of 72. And we want one of these factors to be the largest possible number in this list that we can find. Now, a lot of people will right away think, oh, 9 times 8 is 72, and 9 is in this list. But 9 is not the largest number in this list, which is a factor of 72. If you're not sure which of these larger numbers are factors of 72, pick up your calculator and start dividing. Try 72 divided by 25. Well, that doesn't give you a nice whole number. Try 72 divided by 36. Oh, that does give you a nice whole number. So 36 is even a better number. Try this one, doesn't work. Try this one, doesn't work. And for sure, these numbers are not going to work. As soon as you get to a number larger than 72, you can't divide 72 by any of these and get a nice whole number. So this is the number we want to use when breaking up square root of 72. Square root of 36 times square root of 2. Okay, if you multiply those things back together, you get square root of 72. And now here's why we were looking for a number in this list. Because now that we found it, what is the square root of 36? Isn't that a nice whole number? It's 6. And the square root of 2, well, that's just still the square root of 2. And so here is my simplified, or what we would also call reduced version of this original number. You put square root of 72 in your calculator, you're going to get around 8.48. You put this in your calculator, you're going to get the exact same decimal number, which makes it so easy to check your answer. I don't understand why any student would ever turn in an answer to a problem like this that is incorrect, because it's so easy to check it. Plug this in, get a decimal. Plug the original in, get a decimal. Make sure they are the same. Okay? The reason we call this simplified and reduced is because we have reduced the number underneath the radical sign to be as small as we possibly can. Okay? Now, let me show you what some students do. I always see students do this every year, because I'll put this number on the quiz. I promise you I'm putting this number on the quiz. And some students will do square root of 9 times square root of 8. Because 9 times 8 is 72. And then they'll be real happy because they'll know they got a number in this list, and they'll turn the square root of 9 into 3, and they'll write 3 radical 8, and they'll circle it. They might even check it, put this in their calculator and find out, yeah, that's the same decimal value as this. They'll be so happy they'll move on to the next problem, and then I'll mark it wrong, because this isn't reduced as much as possible. Because this square root of 8 can be reduced even more. Bring the 3 down, and now split up the square root of 8. How could we do that? Square root of 4, square root of 2. And now what's the square root of 4? Square root of 4 is a whole number 2. We have a whole number 3, and we have a radical 2 there. Now you can multiply these two together and get your 6, and here's your radical 2. So if we keep reducing, we will get to the most reduced number If you put this in the answer blank, I'm going to mark it wrong. Writing this answer is very much like, suppose I asked you to reduce this fraction on a quiz, and you put 6/9 in the answer blank. Well, you have reduced it, you just haven't reduced it all the way. 2/3 would be reduced completely. So if you look for the largest number in this list, which is a perfect square, then you'll only have to simplify one time. You won't have to simplify any more. And you get the problem done in a hurry. Let's move down to this problem down here, square root of 300. What's the largest number in this list, which is a factor of 300? You know, if you start from the largest number and work your way down, then the first number you find will invariably be the largest number. Is 100 a factor of 300? Of course it is. Square root of 100, square root of 3. Okay. And then the square root of 100 is just the whole number 10. And the square root of 3 is still the square root of 3. Okay. Let's try one more. Square root of 32. I need two factors of 32. And one of them needs to be a number on this list. And again, I recommend starting from high and working your way down, because again, you know what some students will do sometimes? The first thing they'll think of is 4 times 8. And that'll reduce it a little bit, but there's a larger number in this list that is a factor of 32. And if you need to start dividing 32 by all these numbers to find it, then that's what you need to do. But maybe you realize that 16 is a factor of 32, and it's the largest number in the list. So square root of 16 times square root of 2, square root of 16 becomes a 4, square root of 2 stays square root of 2. There you go. There's another method here that for the video I'm not even going to demonstrate. It's useful when you're dealing with really, really large numbers inside the square root symbol, like square root of 5,000 or square root of 2,029. There's another method which can be helpful. I'm not going to demonstrate it here. For what I want you to be able to learn to do, for what I'm going to quiz on, this one method will be all that you need. It's fast. It's fairly easy. Let's look at numbers on exercises on page 4. I'm just going to quickly do these. Square root of 4 times square root of 3 is square root of 12. I'm going to do these 6 real quickly, leave the rest for you for homework. Square root of 4 is 2. And so here is this number reduced all the way. Square root of 18. I'm looking for factors of 18, and one of them is a perfect square. Oh wait, 3 times 6 is 18, right? Oh wait, but that doesn't help. You can't turn square root of 3 into a whole number. You can't turn square root of 6 into a whole number. That doesn't work. Is there anything else? Oh yeah, 9 times 2. Square root of 9 turns into a whole number. And then the square root of 2 is left over. So there's our answer. Square root of 50. Do you remember that list of perfect squares? Let's see. Let's see. Factors of 50. I know. 25 and 2. 25 has a square root, which is a nice whole number. There's our answer. Square root of 30. There are no numbers in that perfect square list that are factors of 30. So this is already simplified. This can't be simplified anymore. This is sort of like if I gave you this problem. Reduce this fraction 4/5. You would have to tell me, it's already reduced, Mr. Norton. You can't reduce that anymore. Okay. Square root of 60. That one can be reduced. You might have to guess and check a little bit to see which one of those numbers in the perfect square list is a factor of 60. It turns out it's 4, because 4 times 15 is 60. Square root of 4 becomes a 2. Square root of 15 stays square root of 15. Okay. Wait. Could square root of 15 be reduced even more? Aren't there factors of 15? Aren't there? 2 times square root of 3 times square root of 5. Well, yeah, but neither one of these turns into a whole number. If you can't turn one of these into a whole number, there's no value to doing it. So that's as far as we can go. That is the most simplified version of square root of 60. And then this one here, also already simplified. The only factors of 35 are 7 and 5, and neither one of those are perfect squares. Good luck on the rest of the homework.